Have you ever gazed at the sun and wondered if it's unique in the vast cosmos? As it turns out, our sun is but a single star in a universe filled with an unimaginable number of suns, each with its own unique set of attributes. From giants dwarfing our own sun to tiny flickering sparks, each star has its own tale to tell, its own unique fingerprint. Now, imagine a universe filled with a variety of suns, each differing in size, color, temperature, and other characteristics. Size matters, especially when you're talking about stars. The universe is a grand stage showcasing an array of celestial performers, each varying in size, from the humble dwarf stars to the gargantuan supergiants. Let's start small. Dwarf stars, like our very own sun, are the most common in the cosmos. Despite their diminutive size, they have an impressive lifespan, burning steadily for billions of years. Their longevity is due to their slow and steady consumption of hydrogen, the most abundant element in the universe. Next up, we have the middleweights, the stars that are about 5 to 20 times the mass of our sun. These stars live fast and die young. They burn through their hydrogen fuel at a much quicker pace than dwarf stars, leading to a shorter, yet more brilliant life. But the real showstoppers in the cosmic theater are the supergiants. These stellar behemoths can be hundreds of times larger than our sun. Their lives, though, are paradoxically short. The reason? Their immense size causes them to burn through their fuel at an astonishingly rapid rate. The size of a star doesn't just dictate its lifespan, it also determines the type of elements it can produce. You see, stars are the universe's factories. They forge elements in their core through a process called nuclear fusion. The smallest stars can only produce helium, while the middleweights can manufacture elements up to iron. But it's the supergiants that are truly remarkable. They have the ability to create all the elements up to uranium, the heaviest naturally occurring element in the universe. From the smallest dwarf stars to the colossal supergiants, the universe presents a wide spectrum of stellar sizes. Each star, regardless of its size, plays a vital role in the cosmic symphony, contributing to the beauty and complexity of the universe. Not all suns share the same color as our familiar yellow dwarf. As we journey further into the cosmos, we find a vibrant spectacle of stars, each with its unique hue. This brilliant display is not just for our aesthetic pleasure. In fact, the color of a star is a telltale sign of its temperature. Let's start with the coolest stars in our universe, the red dwarfs. These stars, despite their name, are not small in size but in temperature. With surface temperatures ranging from 3,000 to 4,000 Kelvin, they radiate a deep red color. Their cooler temperature leads to a slower pace of nuclear fusion, allowing them to shine for trillions of years, far longer than our own sun. Moving up the temperature scale, we encounter stars like our own sun. These stars, known as yellow dwarfs, have temperatures between 5,000 and 6,000 Kelvin. Their yellow hue is a testament to their moderate temperature. As the temperature continues to rise, we meet the white stars. These stars, with temperatures between 6,000 and 7,500 Kelvin, appear white to our eyes. Their intense heat leads to a faster pace of fusion, resulting in a shorter lifespan than their cooler counterparts. Finally, at the top of the temperature scale, we find the blue stars. These are the hottest stars in the universe, with temperatures soaring above 10,000 Kelvin. Their high temperature results in a rapid pace of fusion, causing them to burn out relatively quickly. But while they last, their bright blue hue contributes to the magnificent beauty of the cosmos. The color spectrum of stars is not just a visual spectacle, it's a cosmic thermometer, a tool that astronomers use to gauge the temperature and lifespan of stars. These colors, from the cool red to the hot blue, paint a vibrant canvas across the cosmos, turning the night sky into a dazzling art gallery. Just as a rainbow displays a range of colors, so does the universe with its diverse array of star colors. The temperature of a star is not just about the heat it generates. It's a fundamental property that shapes a star's existence in more ways than one might imagine. It's a cosmic thermometer, if you will, that influences a star's color and lifespan, and even determines the pace at which it burns its fuel. When we gaze up at the night sky, we observe stars twinkling in a variety of colors. This palette of the cosmos is not due to some celestial artist's whimsy, but a direct result of each star's temperature. The coolest stars, with temperatures ranging from 2,000 to 3,500 degrees Celsius, emit a red glow. As the temperature increases, the color shifts through the spectrum, from red to orange, yellow, white, and finally, at temperatures exceeding 25,000 degrees Celsius, a brilliant blue. But the temperature's role doesn't end with bestowing a color upon a star. It also dictates the star's life story, influencing its lifespan. You see, stars are essentially cosmic furnaces, burning fuel to generate heat and light. And just like a bonfire that's stoked more vigorously burns out faster, the hottest stars consume their fuel at a more rapid pace, leading to a shorter lifespan. Consider blue stars, the hottest in the cosmos. Despite their intense heat and brilliant light, their lives are relatively short-lived. They burn through their fuel at an astonishing speed, lasting only a few million years. On the flip side, red dwarfs, the coolest stars, burn their fuel more slowly and can keep shining for tens to hundreds of billions of years, outliving even the current age of the universe. So, a star's temperature not only dictates its color, but also its life story. It's a cosmic tale of heat and light, of burning brightly and fading away, all governed by a simple matter of degrees. Size, color, and temperature are not the only factors that define a star. Quite like the intriguing characters in an interstellar drama, stars too have their own unique traits that set them apart. Two such factors are rotation speed and magnetic field, which play a pivotal role in sculpting a star's behavior and the potential for planetary systems around it. Imagine a celestial dance where stars twirl around their own axis, each at their own tempo. This is what we call rotation speed. Some stars pirouette leisurely, taking months or even years to complete one rotation, while others spin incredibly fast, completing a rotation in just a few hours. This rotation speed affects the star's shape, its brightness, and even the lifespan. A faster spinning star tends to be more oblate or squashed at the poles, and can also have varying brightness across its surface due to centrifugal force. Now let's move on to the magnetic field. Just like Earth, stars too are enveloped by a magnetic field. Invisible lines of force that extend into space. This magnetic field is a result of the movement of plasma within the star, a process known as a dynamo. The stronger the magnetic field, the more active the star, leading to phenomena like solar flares and sunspots. These magnetic activities can have significant effects on any planets orbiting the star, affecting their climate and even their potential to harbor life. But the dance of the stars doesn't stop there. The interplay between a star's rotation speed and its magnetic field can lead to stellar wind, a continuous flow of charged particles that can influence the development and evolution of planetary systems. These additional characteristics, rotation speed and magnetic field, add another dimension to the intriguing world of stars. They're not just glowing orbs in the night sky, but complex systems with their own set of rules. These additional characteristics add layers of complexity to our understanding of stars. We've journeyed through the cosmos, exploring the diversity of suns. What an interstellar adventure it's been, hasn't it? From the smallest red dwarfs to the largest supergiants, we've seen that the universe is a grand gallery, showcasing an array of suns in all shapes and sizes. We've also learned that the color of a star isn't just for show. It's a visual narrative telling us about the star's temperature. From the cool red stars to the hot blue ones, each hue unravels a tale of temperature, with the white stars sitting comfortably in the middle. And it's not just about size and color. We've delved into other characteristics that make these stars unique. Whether it's the rotation speed, magnetic field, or age, each star has a unique fingerprint, making it stand out in the cosmic crowd. What does all this tell us? It tells us that our universe is rich, diverse, and full of wonder. Each star, each sun contributes its unique traits to this cosmic tapestry. They're not just distant points of light in the night sky, but vibrant, dynamic entities, each with their own story to tell. Next time you look up at the sun, remember it's just one of the many types of stars that paint our cosmos with their unique characteristics.